Welcome to Lunar Shell. Firstly, we questioned the definition of an oasis, which is a calm during chaos that is a safe microcosmos in a cruel macrocosmos. To create a safe microcosmos was guided by the thoughts on how to solve issues of limited water usage availability and reliable energy supply on the moon. Motivation for going on a mission to the moon is to continue exploring and to overcome lunar challenges to achieve secure habitation. The focus of our research was to create a habitat with constant availability of water and solar energy supply. We chose effective solar mirrors. It's the most important and superlative source of energy. It's free, clean, and almost available at any time. A bioreactor is an apparatus used to undergo biological process like water reclamation in the case of needing clean water in space. For collecting clean water from air, we got inspired by desert life. Architectural design for our planetary geological research base is based on the following implement aspects to create a comfortable living environment for the crew on lunar surface: protection, flexibility of the habitat, sustainability, well-being of the crew, of course supporting science, and, very important, easy maintenance of the machines. To introduce our timeline, in phase 1 we start the planning of the habitat components, the prefabrication of the modules and preparing the astronauts. In phase 2 the mission was planned for 2030 to arrive at Lunar's South Pole. The first crew will arrive, and after 1 year we have the annual crew rotation where we continue to expand the habitat. We chose the location of the South Pole at the edge of the Shackleton crater. This heavily cratered terrain site offers diverse geological research such as untouched areas in craters of profitable resources like frozen water. In addition, it is an area of steady illumination, the peak of eternal light. Furthermore, there are life-threatening hazards on the moon. For protection, we used the 3D sintering with regolith from the moon through a robot that allows all shapes in large scales. For the deployment, we have 3 main steps. For the prefabrication on Earth, we have a telescopic cylinder and an inflatable torus, which are the main shapes. After landing on the moon, we have an athlete robot who is positioning the modules on the right place. After connecting the modules, we can set up the whole habitat. The zoning of the habitat is based on private, social, quiet and noisy aspects. We've got 3 big zones. Not to mention that there are separate and overlapping zones. The crew quarter, we designed separate areas for personal privacy in the upper levels. On the ground level, it's all about socializing. The focus on the greenhouse module is all about the relationship between the crew and the plants. This comes with the integrated dining area. This research module is all about sample analysis and planetary research, and in addition the group workout zone. Here we show you the plans of the crew quarter with the volume size, also the greenhouse and the dining area, and of course the research and the group workout zone. These 3 modules are connected with the centerpiece. This is also a place to get in and out of the habitat. On top of this, we have very important water tanks. Bottoms of the water tanks will be shown through a safe haven scenario. Here the life support system is also located in the center. Here on this plan you see the hygiene unit where it's also directly connected with the life support system and the water tanks. For sustainable living, we perform a closed water loop in this habitat. By providing a physical shield, offering zones of privacy, social communication and activities with positive mental effects, the crew will experience the state of being protected and happy. Thank you for your attention, and we hope you love our project as we do.